All right, this is part 2 of Unit 2 Test 2 review. So pay attention to some of the postulates and stuff that I mentioned because you'll see them again on your test, of course. When you make sure you're reading the question too, so you know what's going on. So, for instance, which postulate can be used to prove the following triangles congruent? Well, there's 5 of them: side, 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 angle, side, angle, side, angle, 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 side, and occasionally hypotenuse leg. So looking at this one, you know here, keep an eye out for the reflexive property. That will definitely be something that you will need to be aware of. And then as you can see, this is going to be side, side, side. Alright, this one, again, reflexive property, but we got an angle and another side, so this is very simply side, angle, side, side, angle, side. So side, angle, side. And then over here you have side, an angle, and a side, angle, and a side. It matches up, so this is also side, angle, side. Alright, so this was the most missed problem basically on your last test. State what additional information is required in order to know that the triangles are congruent for the given reason. So, for instance, we want this congruent by angle, angle, side. We have one angle. Alright, we need to add another angle. So I'm just going to let's do this one. We would need to know angle D congruent to angle S. That's part of the question. Alright, got the other angle. And now I want a side. I don't want the side here because that would be angle, side, angle. So I want angle, angle, side. Angle, angle, side, and then tell me what you just added. UD is congruent to US, and that's all you have to do. Alright, hypotenuse leg. We got right triangle, none of the sides are congruent, so we just need the hypotenuse. Alright, so let's look. This is the hypotenuse. Okay, so that's WX congruent to KV. And then let's just make any other leg. You could do this one and this one, or this one. Let's just do this one so we can see the reflexive property again. Let's make XV congruent to XV. So now you've got the hypotenuse and a leg. It could have been this side, but it doesn't matter. And then angle, side, angle. So again, we got an angle, two angles that are congruent. We got a side, so we need another angle. And we need it after the side, so we need to go angle, side, angle. Let's just make one here. And then angle, side, angle. So we just added angle right here. That's going to be SPQ congruent to angle RQP. Okay, and that's it. So most missed questions, not hard. You get to add what you need. So just be careful with it. All right. So given the figures, card congruent to POTJ, complete each congruent statement. CA is going to be congruent to PO. Angle J would be congruent to angle D. And TO would be congruent to, so look, TO would be congruent to RA. And that's it. Now over here, complete the following proof. Make sure when you see these proofs, you're very aware of the reflexive property. You're very aware of vertical angles. And also be aware of midpoint, vertical, reflexive, and alternate interior angles. Okay? Just be very aware of those. So let's see what we have here. So W is the midpoint of VU and ST. That's what adds these here. Angle V is congruent to angle U. And really, we don't know that these are all the same, so they should be different. But regardless, let's mark the given. For time's sake, I'm just going to write the given here. But on the test, you need to write all of this out in here, and you need to give the reason as given. Now we know these two pieces, so W being the midpoint of PU and ST means that these two pieces are now equal, or now congruent, and that is by the definition of midpoint. Oops, sorry, out of screen. Okay, you got to know that one. And then we went in and we said, oh, vertical angles are congruent. Let's figure out what it is. VWT is congruent to UWS. Oop, W. Okay. Oh, and by the way, you know what you're trying to prove those come last. And this time it's a piece of something. Okay. So we can't just automatically say, oh, V and U, that's the same. We have to say that these two triangles are congruent first before we can say every little piece is congruent. So we can now prove these triangles congruent by V, let's call triangle VWT, just use your angle names, congruent to triangle UWS by side angle side. And anytime you want to prove a little piece, everyone's favorite, CP, CTC, corresponding parts of congruent triangles are congruent. Okay, all it means is corresponding parts, all the pieces, all the same pieces of two congruent triangles, two of the same triangles are congruent. Okay. So flipping over, this is a big deal. You need to know isosceles triangles. That if you have two congruent sides, it's isosceles, and therefore the base angles are congruent. This angle would be congruent to this angle. Make sure you can identify your base angles. So this is also 52. So I have 52, 52, and this, and all of that adds up to 180. So let's do 52 plus 52 is going to be 104 plus 6. It's going to be 110 plus 14x. So I'm just trying to, you know, cut some corners here so we can be able to move a little quicker. So all I did was combine my like terms, 52, 52, and 6. Subtract the 110, 14x equals, what is that going to be, 70. Divide by 14, x is going to be 5. Okay. This is also isosceles. You see this angle, or this side and this side are congruent. Therefore, you know your base angles are over here. It kind of points to them, right? So if that's 54, that's 54. So 54 and 54 is going to be 108 plus just the x equals 180, because you know everything in here adds up to 180. Subtract the 108, x equals 72. Finally, you have a bunch of these little equilateral triangles. First off, make sure you know that if like this 4x is on this side, it's talking about a side, not a degree. The side lengths will never equal a degree measure. So find something that it's congruent to. It's congruent to this 40 over here. So 4x equals 40. Divide by 4, x is 10. Now, this angle right here, all right, in an equilateral triangle, the angle is always 60. So no matter what this is, set it equal to 60. Period. It could have been 2y. Say 2y equals 60. You would know y would have to be 30. Okay, so no matter, anytime you see an equilateral triangle, it's always going to be 60. Now this, I'm going to let you do on your own, but really, you need to know about the rhombus, rectangle, and square, because I think we're okay on our parallelogram properties. diagonals bisect each other, opposite sides congruent, so on and so forth. But the problems down here will kind of explain that a little bit more, so you can come back and finish these in. So ABCD is a rhombus. Angle ABC is 80, so go find that real quick. ABC. So this whole angle is 80 degrees. In a rhombus, the diagonals bisect these angles. And first off, remember that this is a parallelogram, so if this angle is 80, guess what this angle is? Also 80. And then what do we know about the consecutive angles? They are supplementary. So if this is 80, the consecutive angles right here, this would need to be 100, and this would need to be 100. Now, the big property in a rhombus is that the diagonals cut these two angles in half. So if the whole thing is 80, then this needs to be 40, 40, and sure enough, down here also 40 and 40. If this angle is 100, it's 50, 50, 50, 50. The final big, or one of the other big properties about a rhombus when it comes to the diagonals is that in here, every single one of these angles is a 90 degree. So you want to know that the diagonals bisect the vertices, or in other words, the angles where they start from, and that they are perpendicular. Okay, so looking at BAD, that's this big angle down here. That was 100. Looking at angle 4, we found that to be 50, because if the whole thing's 100, cut it in half, so you get 50. Angle 5 is right here. It's half of this big 80 degree angle. Okay, so you get 40. And then CED, again, that's this angle here, so it's always going to be 90. Every time, in a rhombus, only in a rhombus. Contrast that to a rectangle. So if you know that the difference between these two, you're in great shape. In a rectangle, the big difference is you always get 90 degrees, and the diagonals are congruent. So if you ever draw a rectangle, you can kind of see that. Over here, you can see that this diagonal is longer, and this one's clearly shorter. So looking at this rectangle, RG is 2x minus 7. ET is 30, so this whole thing is 30. So we want to figure out everything about now. So here, the diagonals are congruent, so this is what happens. They're all the same. So if this whole thing is 30, these get divided up into two equal pieces. This would have to be 15, and this would have to be 15. And therefore, you would know this is equal to that, congruent to that. So you would just say 2x minus 7 equals 15. Add the 7, 2x equals 22. Divide by 2, x is 11. So x is 11. And then, we know EG is 15. GC is 15. And then RC, this is 15. RC is the whole diagonal. This is 15. We know it's 30. The only other thing you might need to be aware of, you got isosceles triangles here. If you know, say, this angle was 30, you would also know this angle was 30. And if they're 90 degrees in the corner, know that, if that's 30, then this would have to be 60. This would have to be 60. They would have to add up to 90 here. So you can kind of go through and see base angles being congruent. Here, 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 and there. But if you have any questions, let me know. I'd be glad to help you out. And if you can do this, especially know the difference between rhombus and rectangle, you're in great shape. Okay.